Okay, welcome to the first practicals. Yeah, to the first practicals of object-oriented programming. I'm Julia, so.
Yeah, and I'm Michi. Probably you know us from Introduction to Structured Programming. Also there we did the practicals.
And it will be very similar from how we structure in general the lecture and the practicals. So, yeah.
Okay, a bit louder. Does everyone? Okay, now it's better, I think. Also for you? Mm-hmm. Yeah, okay. So what is our plan for today? First, we start with some organizational matters and also describe what we will do here. And then we mainly repeat the topics that you have learned so far in the lecture, which consists of classes. Yeah, so last time you had a very giant lecture about classes, and we'll repeat most of these topics today. Also have a look on the STD vector again. I think you learned it in the first lecture. Have a close look on the debugger, and then, if time permits, we'll also discuss dynamic memory, which you have also seen last time.
Yeah. So we hope to recap everything you did in the lecture, but now a bit more on the practical side. So we're trying to implement some examples. Okay, so for the organizational matters, well, we do not have much yet, just the practicals. As in Introduction to Structured Programming, we'll be recapping the lectures and doing more practical stuff. We will also have additional explanations. And of course, the most important part, we'll be able to answer your questions. So if there are any questions, if there is anything unclear, we can always answer them.
So just ask if you have any questions. And one more thing, I hope everyone noted this last time, there's also already a homework 1, where you recap the basic implementation of classes. There are a few questions that you need to implement, some classes, and also I think one additional question which is related to references directly in the Teach Center, and you have 1 more week to go for the homework 1.
And we are using this new Teach Center activity for the first time, so if there are any problems, please let us know on Discord.
Okay, that were the organizational matters, and now we directly jump into our first topic for today.
Okay, so we want to start with an example of how to implement a class. So we'll start with a very basic class. I want to store an ingredient, which I want to use later for maybe a shopping list, maybe a recipe or something. And so what should an ingredient have? Well, we want a name, we want a unit, and the amount. So the amount could be 500 and the unit could be grams. Yeah. And we also want a way to print this.
Okay, so now maybe switch back to the ingredients. So I think we have seen very briefly UML diagrams. Does anyone remember the plus and the minus in front? Yeah?
Yeah. Yes, so minus are private members and plus are the public ones.
And so why do we choose the attribute, so the name, the unit, and the amount to be private? Simply because we don't want anyone to get into our class and modify those things unless we allow it by some public methods. And we will see this structure now.
Yes. Maybe I make it a bit bigger. Okay. Okay, so we'll start directly here in the main. First, we want to create a class. So in C++, if you have seen, we'll just use the class keyword. Okay.
I think we need to switch off the cheat mode. So I've still activated. Okay, no, it's already, I think.
Really?
I think so. Yeah.
Okay. Okay. And we had 3 members of this class, namely name, unit, and amount. And as we have said, because we don't want anyone else to modify our internal state of our class only through the methods we provide, we will make them private. So the name, of course, will be a string, and we'll use these new C++ strings. Yeah, I think in C++ now you will always use std string because it's just way easier to work with. Then we also want the amount. Which will just do a double. And then now we somehow want to store our unit, but with what data type? Well, we'll use also something you've already seen, namely enums, but now in C++ we'll make an enum class. And as you've already seen in the lecture, this enum class gives us some nice properties with this enum so that we can only, for example, access the enum enumerations through our class. Because if you remember in C, these enums were just constants more or less, which you just could use everywhere, but now we really have a type we can use.
So in this case, this really must be, for example, a unit gram and not just the constant gram here.
Yeah. Yeah, because maybe if you remember from C, a enum is just something like an integer where each member of the enum is just, for example, 0, 1, 2, 3. And if you just write enum in C++, it would behave pretty similarly. But if we use this enum class, this helps us really distinguish that this is a unit. And if we then expect a unit in a function, for example, we can't just pass an integer. We really need this type. So in C++, you should always use this enum class instead of just a normal enum. Okay.
Can we already create an object of ingredients now?
Well, we can try. Next difference to see, we don't need a type def if we use this class. But I don't know, maybe create apples. And if we now want to create this, well, okay, we have this now, but we can't access anything. And also, maybe we would like to initialize it. So we actually want to give this a name. I mean, we could try it like this, maybe. I know 500 apples. But we get an error now because no instance of constructor ingredient matches the argument list. This is because we made everything here, we declared these attributes as private, so we cannot access them or initialize them with a constructor because we need to provide one. This is different if we would have made them public. Then we get the default constructor which initializes everything. But we'll implement this ourselves because we want them private. So how do we create a constructor? Well, it's just more or less a function which you don't need a return type because it's a constructor. And then we want to give this some parameters. So we get a name, an amount, and a unit. And then we've also seen something which is special when we declare a constructor, the initializer list, where we can directly initialize members of the class. So you can just say here name, and then call the constructor of name, and there we can just pass this name, which will then copy it to our class.
Okay, so that's the constructor. And we initialized all the 3 attributes of the class with the corresponding values. We call the constructor in the main function with 3 parameters. Okay, the constructor expects 3 parameters, so this should work. Maybe we can compile it, the whole thing, and check out whether this really works. Okay, now when we compile it, of course, we need to use Clang++, because we're dealing with C++ programs. Yeah.
Yes, that's a very good question.
We will repeat the question for the recording. Does it matter which kind of brackets we use in the initializer list?
Well, it's the same as if you call the constructor here. Here we are also using curly brackets, but we can also use the round ones. But why do we use the curly ones?
Basically, the curly ones are a bit better in the sense that they do more checks on them. So if we would like to initialize the double, we need a double here to initialize it. And if we use only round brackets, then we could also enter an integer or something which can convert to a double. But with the curly brackets, we really ensure that only a double is passed to the attribute.
So it's a similar situation to the enum class versus the enum. We just use it because it gives us more compilation errors, which is good because this could help us catch some mistakes because we accidentally passed the wrong type, but we used the round brackets and now it's automatically converted, but we didn't intend to do it. And this just helps us preventing errors while we code.
Okay, now the Clang, yeah, it did work. Main CPP, same as usual. We need to specify the source file -o and then the name of the output file, and we execute the program with /main, prints hello world, and we don't see anything of our apple because we don't do anything with it except for creating it.
Yeah, but maybe we want to print it.
Okay, let's try to print the apple.
But this wouldn't work because we just implemented this class. C++ has no idea how to print it. And if we just want to print the name, this of course also doesn't work because we made it private.
No, that's annoying. So how can we get access to the name then?
Yes. Yeah, we need a getter and, for example, also a setter, but just to access it, we could write a getter.
We'll do it for the amount now. Okay. So very basic function. It just takes the attribute and returns the value of it. And now if you print the amount, for example, here.
So now, I did the amount, not the name. But now we can call the getter instead of accessing the attribute.
Does this work now?
Yes.
The amount is printed. Okay.
Another thing you've seen in the lecture are why we would make this getter const here. Does anyone remember what this const here does? I think you did this in the lecture, right?
Okay, yeah.
Yes? Yes, it makes sure that the function does not change any values. So it makes sure that in this getter here, we can't change the amount because this is not what we want. And if we call getAmount here, we also see here that this is const. So we know that when calling this function, this does not change our class. And this could be very useful when using this function, just so you are sure that there's not anything that happens. And it also prevents us here from accidentally changing any attribute in our class.
So this const, or a const method, really helps us during programming that we don't make mistakes where we change something unintendedly.
Especially, for example, if you're working in a team and you have some function another member of your team uses, and then this function suddenly changes something in your class that you didn't intend to, this could lead then to some problems. But if you make the function constant, everyone knows, okay, this does not change the class. And you can also rely on that because it would give you a compilation error.
Okay, now we have access to get amount.
Yeah, I'll
okay.
also.
So one more getter here.
Yeah.
So it's always the same principle. We have the return type of the attribute. Usually for the getter we write the const and then we return simply the name.
Yeah. And yeah, as you have seen, you can just change these, chain these outputs together with this left shift operator, more or less.
Okay, and then we have Apple 500. Okay, what if I want to change something now in the class?
Yeah, so for example, if we want to change the amount, because maybe there are too many apples, then we can do something like this, again, because it's private, as we've seen before. And this also wouldn't work. Yeah. It also gives us an error because we can't set something that this function returns. So we need a setter. Oh. So this time I won't make it const, but we need an argument. We could call it new amount. And now we can call set amount with a new value. And yeah, and hopefully it changed.
Maybe we can print it one more time afterwards.
I'll copy this down here. And yeah.
Okay, so maybe we also show the setter here. Okay, so now we did maybe a complex, no, not really complex, but like it seems to be an unnecessary construction. Yeah, we have for the amount now the setter here to set the amount, and somewhere up there, maybe move up the getter for the amount to obtain the value from the amount. And this is simply because the attribute is private. But why should we do it like this? Do you have any suggestions for that?
So why not just make amount public and then directly access it?
Somebody an idea. Why should we do it like this with a setter and a getter? Yeah?
For the getters, they control how attributes when they are put in, when creating an object is controlled. For example, you can set constraint for your input, and if our input is passes that those constraint, then it can be set to our attribute of the object.
Okay, so I think you mean the setter, that if you get something, for example, a new amount, we could do some sanity checks that it's, for example, not a negative number or something. Yeah.
Okay, yeah. This would make a lot of sense, yeah, because new amount to be negative, how to buy an ingredient for a recipe which is a negative amount. This is not very meaningful.
Just in general, it's just if we have something in our class, some invariant, so just something that can't change, that always needs to be true about our class, for example, that the amount is a positive number, then we of course can check this in the constructor, is the amount positive, and then we set it. But if you then make this attribute public, then someone could just outside of the class set the amount to a negative number again, and we wouldn't expect that. And therefore, if you write a setter and always set it via the setter, we can be sure that if we're in a method within the class, that we always have a positive number for the amount.
And there's one more reason. Why do we need to have the attribute amount in our class as a double? Maybe we are very funny and want to store the amount now as a string. we can do this with this construction. Now we could simply change the amount, the attribute amount to a string.
Do it.
Yeah. And then we implement the getAmount function in a way that we convert the string to a double. And it would still work. So all programs that used your getAmount getter, which returned a double, would still work, even though we changed something completely in the class. But if you rely on this, that amount is a double and access is directly, and now we change something in our class implementation, your program would not work. But if we then update the getter accordingly, that it still returns a double, although we store the amount as a string, we can reuse everything.
Yeah, so we can change this attribute, and then in the getter, just convert the string to a double, and in the setter, the double to a string, and also in the constructor, and then everything would work the same from the outside, but we changed completely how our class works.
So these are benefits to have this form of encapsulation where everything of the attributes are in the class and not accessible from the outside. And from the outside, we clearly provide what you can do with the class, what you can change, what you can get, in which way you can get it, in which way you can change it. But it really depends then on us what we do with this information, how to store it, and so on.
But now printing and writing all these getters and setters can be tedious. And so how could we solve this? Well, we could just implement the functionality within the class where we have access to all of our attributes anyway. So we can just write a print method, which will make const, because it should just print the attributes and not change them. And then print in here, and then we can just call this, and we don't need any of the getters and setters, because in the print method, we can, of course, access them without it. So maybe if we just make a list, then we'll start off with the amount. Then I will also want to print a unit.
Now the unit is a bit annoying because it's an enum, and how to convert an enum to a proper string.
So I'll just write a switch case. Yeah. Maybe also to milliliter. And maybe also...
They were a bit lazy. Okay.
Yeah.
And maybe we want to add also the name.
Yeah, the name.
Okay, there was one question, yeah.
The question was if it is possible to convert the name of the enum to a string. No, sadly not. I think this is something many people want to do, but it's not possible. Yeah, also not as same as in C. You can just do something, some wild thing with macros, but
yeah, maybe you can basically take. So if we hover over them, I hope they also the enum. Also refers to an integer, maybe used as an index for an array where you
this is
store
possible.
the strings.
But you still need to type them out, so you cannot convert the name to something.
This is unfortunate, yeah.
Mm-hmm.
Do we have to add break?
Yeah, do we have to add break? Yes, we need to add break.
Did you do that on purpose or did you forget? No, you don't have to answer this question. Okay, maybe we test our print method.
Maybe I should also call it. So instead of doing this,
okay, so
yeah, okay, I didn't implement this, so maybe let's do something I actually implemented.
okay, so we really have this print statement executed, and we want to buy 10 grams of apples. So this is like one very small bit of an apple. Okay, so this works, and now we have like a very nice function to print the apple. At some point later in the course, we will also see that it's possible to print an apple in a way that we can print strings or doubles or whatever, so that we can just write it in the std cout.
So something like this.
But this is a bit too hard for now, so we'll wait for, I don't know, 2-3 more weeks, and then we will see how to do that. But such a print function is then already really fine, because now we don't have code in the main function or any other function that is concerned with the printing, because it makes a lot of sense that the whole printing is in the class of the apple, because the apple knows how to print itself, or the ingredient knows how to print itself. It's not necessary that this is somewhere outside and unrelated to the ingredient, because this is strongly related to the ingredient. It's like kind of the terminal representation then for us. So it should also belong to the ingredient class.
So maybe think before writing hundreds of getters and setters, could this just be a method within the class so that I don't need to write any getters or setters? Because it is always nicer, I think, to write some specific function within this class instead of writing some generic getter and setter.
Yeah, so if you observe something like you call 3 getters of a class, calculate something, and then call a setter of the class, usually you can just write a function inside of the class, so a class method, and put the code there, and usually it refers then to the class, and nobody else needs to know how this calculation is done. It can be directly done in the class. Okay, do you have any questions? Should we maybe switch to the partitioning in files and then continue with the vector, because it's a better overview?
Okay, yeah. Yeah, okay, we also have the code on the slide, so you can look at this later. So, where do I have it? Here. So you want to continue with multiple files?
Yeah.
Okay.
Because simply, if you go back to our code and maybe scroll up to the, then we have like the enum class, then we have the ingredient, we have all the getters, setters, the print, and then the main, and probably it's already hard for you to follow what we did and where everything is located. So the question is now, can we do this better, and maybe can we structure our project in a better way?
Yeah, so if you already did design your app learning C, then I think we've already shown you how to do it in C. So how to write header and source files in C, and it's very similar in C++. But for all of you who didn't do this, a quick recap how to do this. So multiple files, we use those because, well, if you write everything in one file, as you did in ESB, this can get really long, and also maybe you will really need to scroll around to find some function, find a class, and it can get pretty confusing. So we'll separate those out in multiple files. So you have like a class, one file to do one thing, and that's it. How does this work in C and C++? Well, there's some header files and some source files. The header files are these .hbb files. There we'll just put the declarations of our functions, classes, enums, structs, whatever, so the declarations, and then the definitions go into the source files, these CPP files. And then you will just include the header file, and yeah, so now you may wonder, so how does this other file know about the definitions if I just include the declarations? Well, if you compile the program, then you need to specify all CPP files, but not the header files, because you included the header files in the CPP files. So then the compiler knows about everything you did.
So basically, the CPP files are implementations, and you need to compile them, and the header files are overviews, what is happening in the class, what is there, and is used then in all implementations.
Yeah, so we specify the C++ files, not the header files, and yeah. I think we'll just do this by example, and then this should be clearer. I think we already created an ingredient header file and source file. So I'll open this side by side. What you always need to do in a header file is write a header guard. So what is this? It's just this. You can also then copy it from the slides if you want. The important thing here is that you need a unique name for every header file you have. Well, why do you need this? I think we actually saw this in the lecture, why you need these header guards. It's because if you include this header file in multiple C++ files, we only want these declarations once and not multiple times. And what happens here is we just check if this constant ingredient HPP is not defined. Then we more or less execute the code in here. And in here we define it. So if we get here a second time, we won't do anything.
So basically, this means that the declaration of ingredient only exists once. And if we would like to include it a second time, then the ingredient is already there and we don't execute it.
Yes. So what do we write in our header file and what do we write in our source file? We said in our header file we want all declarations. So we want the enum and the class in the header file. But in here, we also now have these definitions of these functions. And this is what we want to move into the source file. So I'll include string also in the header file, and I think
this should suffice.
Yes. So what do we want to do in the source file? We include the header file like this, and then we now want to write this print function in the source file and not in the header file. So what we'll do is we need to specify which class this print function belongs to. And everything else has to match what we have in here. So the name, the return type, if something is constant, this has to match in here. And we need to specify which class these functions we want to implement. Because, for example, in the header file, we could have multiple classes. You could include multiple header files. We need to know from which header file or from which class we want to implement this print function. Therefore, we need to specify this. And then in here, we'll just implement,
I'm sorry, 2 spaces.
We'll just copy everything from the class. Oops. You also need to include IO stream. And now we have this print function in the source file. And here, we don't need to define it. We just write a declaration as you're used to from C, as you already did in C. In Introduction to Structured Programming, when you declared your functions at the top and then implemented them. Some of you did it.
And now this makes it already a bit better, because now, like, this print function, the implementation of it is separate from the class. And if I'm not interested how the print function works, but I just want to know what the ingredient is about, I don't have to have a look on the CPP file. I can just scroll through the class declaration here in the HPP file and basically see what is contained there.
Yeah. When you implement the assignment, this also helps just having your comments in one place. So you can just comment your function in the header file, and then in the CPP file where you actually implement them, you don't need to scroll over your many comments that you wrote.
One more thing maybe, maybe you can go to the HPP file to the very top. Now we have basically here two data types defined in this HPP file, which is the enum unit and the ingredient class. And in our course, we have the rule of thumb that in every HPP file, there should be exactly one class or one data type to be defined. This would be an exception here because the unit is strongly related to the ingredient. The unit is just used in the ingredient because, yeah, we need it there as a private member. So this would be okay. But as soon as you have two actual classes, so maybe an ingredient and a recipe, then the ingredient and the recipe should be in two different header files, and their implementation should be in two separate CPP files.
Yeah, especially with enums, you often have the case where you want to put them in the same header file just because it belongs to some class you want to use. Yes?
So if we have an example of multiple enums that we use across multiple different classes, should we have is it the convention to have a file for every enum, or can we just put all the enums in the one file, like call it definition of enums?
So if you have multiple enums that you want to use in multiple files, should you put them in one header file or each enum in a separate header file? And I think you can put it in one header file. If they roughly belong together, you could, for example, also split this in two header files, some enums in one, some in the other. Just, depends on how they belong together, how many there are.
But if you have 10 enums, you don't need 10 files.
No.
Yeah, so just group them together. This is fine enough.
So our main function is still showing an error. And this is because it says ingredient is undefined. And this is because now we need to actually include the ingredient header file in the main. So we do not need to include the source file, just the header file. And if we do this now, everything seems fine. Now if you want to compile, we not only need to specify the main, but also the ingredient. And now we need to specify the source file. So the source file when compiling, and the header file when you're writing your code everywhere else. Okay. Yeah, and it seems to work.
Okay, very nice. Any questions regarding the splitting into the HPP and CPP file? Okay, so this looks now much cleaner than before, and now I'm more willing to start with my part. So go back here to the vector. Yeah, so you have seen this in the first lecture of OOP. And what is a vector? So basically when we worked in C, we created arrays or maybe linked lists to store multiple objects of the same type. And now in C++, there exists this std vector, which is really nice because it does all the memory management for us. So we can use it directly without being bothered to allocate memory for the array, move the array, shrink the array, whatever. Everything is already pre-implemented. And we can already now say that std vector is just a class. And this class has some private attributes that stores then your objects. And again, we have methods on the vector class where we can access our objects, access the length of the vector, and so on. So here in this example, we create a std vector. And now one special thing about it is it must know its data type. So what is the data type of the elements that it stores? And now, okay, we can say integer here. We create the variable name and initialize it with these three integers. We don't need the equal sign. We could also write it like this because it's more or less a constructor here.
Yeah. So you know, I think from C we also have shown you this initializer list where you can initialize structs and arrays, and you can think of this as pretty similar when you now that just you're calling a constructor with this initializer list.
And yeah, as one expects now, these three elements are stored in the vector. So maybe we could output the size of it, and then we call this pushback method, which does a very natural thing on the vector. It just appends an element at the end of the vector. So of course it must be an integer because the vector is of integer type, and we would append the element 4, and if we then print the size of it, it should be 4. Let's see whether this works here. Okay, yeah, so this is the output of the program. First the size was 3, and then it was 4. Okay, so we have a constructor of the vector, a size method, and a pushback method. And also one important thing, how to access now the elements of the vector. And here we saw that we use the method add with an index. Yeah, so if we enter now 0 as an index to the vector, then we go through the list of the elements which are contained in the vector and take the 0th one of it. Yeah, so if we run this now, yeah, we get 0. If I would put in here 2, for example, then I will get 2 as an output. And if I add maybe 3 here, what would then happen if I want to access the vector at the 3rd element? Yeah, an exception, yeah, or differently spoken, our program crashes. Yeah, we get some weird error here. Okay, now this is regarding accessing elements, and now, yeah, we want to use the vector with our ingredients to maybe make a shopping list. Yeah. So first thing first. As always, we need to include it so that we can use vectors. And yeah, maybe, I think I don't need your code anymore, so just remove it. Okay, now I will create a vector, and now we said, okay, we need to specify the type of it, and it should be of the type ingredient. And let's call it maybe shopping list. And yeah, maybe I can use directly an initializer list here for our elements. What are our elements? Now they should be ingredients. So maybe I will take the apples here from before. So this should be the first element in the vector. But we don't need a name here because we don't want to store like variables here. We directly create the ingredient here. So an ingredient object is created, and this should be at the position 0 in the vector. So we don't need to write the variable name here for it. What could be a second ingredient? Any suggestion? Maybe we want to have milk. I think we have milliliter somewhere. We take the unit milliliter. And maybe we take also a third ingredient. What have I prepared? Maybe eggs, yeah. I don't know, 12 pieces, or 12 units of egg. Okay, and so now we have already this std vector with the shopping list with these 3 elements contained.
Yeah. So with this angle bracket you have here, we'll learn later in this course what exactly this means and how this works. But for now, you can just think of it as specifying a type your vector should have. And because we specified this type, if we now write something different here, we'll also get an error. We somewhere get an error, but not in here.
Yeah, we just run it, compile it, and we see, okay, 1 error generated. And a very long and ugly error message.
But it points us to the right direction, that there's no constructor for our vector, which then takes a string.
Okay, so now we have created our vector consisting of 3 elements, and now maybe we would like to print the elements of our shopping list. And now the probably easiest approach to think about it, okay, I need a for loop. I need some integer type. Maybe I use size t, which can store any integer that is realistic in this case. Set it to 0 to access the first element. then iterate it until we have the length of the shopping list, and increment it always. And now we want to print something. Okay, basically I cannot do it like this. I want to do I take the shopping list. I access the shopping list at the specific index. What is this now? Shopping list at I. This is now an ingredient. And if I have an ingredient, I can call the print method on it that we implemented before. So I can iterate now through the vector, access the elements, and call the print method on them. Okay. And now let's try whether that works. Okay, so we have this 500 grams of apples, 1000 milliliter of milk, and 12 eggs. Okay, so iterating over this actor works. And maybe also to demonstrate this, we go now shopping, and then somewhere we see some chocolate and want to add the chocolate to our shopping list. We can also call pushback here on the vector. Again, construct an ingredient, and this should be now chocolate, I don't know, 100 grams. Okay, maybe clean this up a bit.
Yeah, here you really see that we are calling the constructor because we are really doing it like we have in this header here, where we are calling this ingredient constructor here with the parameters we have specified here.
And then this ingredient object is taken and added to the vector. And now we could print the vector again. And now I want to show a different way to print it. We still need the for loop because we have to iterate over elements. But we also saw the so-called range-based for loop in the first lecture. And this works a bit different because we specify the objects that we want to iterate over. So the vector consists now of several ingredients. So an element during iteration will always be an ingredient. Maybe call it ingredient. And then separated with a colon, we specify the element where we iterate over. So this is the shopping list then. And now, instead of calling shopping list at I, at the specific index to obtain the ingredient, we directly get the ingredient at the specific index in this ingredient variable. So this is more expressive because we already know what we're doing here, so what object we have to deal with, and we can simply call ingredient.print on it. Okay, maybe let's try again. Okay, now it's not properly separated. Maybe we do something here. New list. I'll run it again. And we see, okay, on the new list, we still have the apples, we still have the milk, the eggs, and then we added the chocolate. And also this works here when we iterate over it. Maybe I want to show you something different. So let's remove the first for loop. We don't need it anymore. Let's assume the chocolate is already in the list. We have a for loop to print it. Okay, keep it. And I want to add a second for loop. And now I do something ugly here because we've just one getter. So we just say we need to buy a lot of things. So let's set the amount to 10,000 for each ingredient that we have. So just to recap this, so we have our ingredients list. We also add the chocolate to the end. Then we iterate over the shopping list, set the amount of everything to 10,000 that we have never to go shopping anymore, and print the list then, and print new list, iterate over the elements, and call ingredient.print. Should also work. Let's check it out. but I mean, we set the amount to 10,000 every time, and now we have still our old values here. Why is this the case? Yeah? Completely correct. In the for loop, this variable here is just a copy of the elements that are contained in the vector. So we take the copy, set the amount to 10,000. Okay, after the for loop, the copy does not exist anymore, and still the old vector remains. Okay, so we didn't change anything. To overcome this problem now, we usually use in the for loop here references. So we don't iterate over copies of the elements in the vector, but over references to the elements in the vector. So basically, we really iterate all the elements in the vector, not just copies of it. And if we now set the amount to 10,000, then it should work. And actually, this is the case now because we modified the references, we modified everything in the vector to be 10,000. And even if we take copies here during the printing, we already modified the elements of the vector. We just take the copy here, but we don't change it, so it doesn't matter. But still, we can also use reference here, because then this avoids the copying of the objects, which is a bit unnecessary in this case. So you can basically always use the references in such for loops. And if you want to be sure that your objects don't get changed, you can also write const here in front. So you have a const reference. So it is the same object as in the vector, but you cannot modify it. And when we print it, this is what we want to have. If we do it here, then we should hopefully get an error, because we said we iterate over the elements and we will not change them, but actually we want to change them, so we cannot write const here.
Yeah, so why does the compiler now know that set amount changes our ingredient and print doesn't?
Yeah, why does the compiler know that we can call print on the ingredient, but set amount is not allowed in the case that the ingredient is const?
Maybe he looks in the function definition.
Yeah, this is true. So it looks, to have a look on the set amount and print function. Okay, where are they? Here's set amount and here's print. And there is one difference. The print function is const. So it's ensured that nothing changes in the ingredient. And that's why we can call print on the const ingredient. But set amount is not const. It cannot be const because it changes something. And for that reason, we cannot call set amount on a const object. So if you use this const properly, you can really be sure that nothing bad happens or nothing unintended happens. Because if you always write const when you don't want to change something, you have the guarantee that you can always that you can only call const functions that do not change anything. So you can really work with that and make your code safer. Okay.
Yeah, so you can really specify in this for loop here on the left-hand side different types, like you would when you assign an element of the vector to a new variable. You could give this new variable just the type ingredient, then it's the same as in C, where it's copied. You can make an ingredient reference, and then you just get the reference when you access the vector. So, yeah.
Now, one more small modification we have. If we don't want to write ingredient here, because either we say we don't want to write so much things, or we say it's very obvious that it's a vector of ingredients or just ingredients are contained, we can also write auto here, and C++ will automatically know that the elements of the shopping list must be ingredients, and hence the data type is also an ingredient here. And if I hover over it, it also states that it's an ingredient.
Yeah, just note that if you just write auto, it would not create an ingredient reference, but again a copy, because then outer would just be ingredient.
So you need still the reference, or you can also specify the const as well. You can also have a const outer.
No, it does not tell you the reference with the const. Okay.
But it should here.
Oh, yeah.
Here it tells us everything. Okay, so far the vectors. Nice thing about it, we don't need to free anything now at the end. Vectors will free everything again, and we don't need to be bothered with that. Now, debugger, right? Okay. So maybe some of you use the debugger in C. I hope many of you, because it's really a nice tool that you can visualize your code or the execution of your code at certain time points. So for example, we could figure out why the setter didn't change the elements of the vector. And also this is possible in C++.
So setting up the debugger is the same as in C. We just want to show it to you again because using the debugger is something you really all should do if you have a problem in your code, because it's because you get a way better understanding than just inserting prints everywhere.
Okay, the checklist, what do we need to do? In VS Code, we need the code LLDB extension. So let's check. Hope that it's LLDB. Yeah, so this extension, okay, I already installed it. You need to install this extension first. So just go here, extensions, and install it. Then, okay, maybe we should then, how to start the debugger. So we go here on the left side to this run and debug section. Press run and debug. Now, of course, we want to do it with LLDB. And now we get an error message, which is probably too small that you can read it. It just states, cannot start debugging because no launch configuration has been provided. This is fine. Yeah, so we press OK. And then this launch.json opens, and you can also find it in the VS Code, in some hidden VS Code folder, launch.json. And yeah, basically, one thing you have to do is you need to update where your program is located. So don't change the workspace folder, but then just continue with here where the executable file is. Now we are in the folder KU slides, and our executable is this main file here. So we need to go in live coding, then in recipe, and then in main. Okay, so this should be the correct path. Now maybe close this again. It's all getting a bit messy. And now when we compile the whole thing, we need to write -G to activate the debugging symbols. So now we compiled it, and now if I go to the run and debug session again and press on the run button, then yeah, okay, it went through, and now we can also set breakpoints, for example, here. So on the left-hand side, we can set the breakpoint. If we now run and debug, then we will stop here, and we can also monitor our variables. So we have the shopping list, and we see the shopping list now. Okay, maybe I can close this here. Okay, yeah. So the shopping list consists now of 0, 1, 2, 3 elements. Yeah, we had 4 elements in our shopping list. If I open them, I can also see that each element consists of the attributes, the name, the amount, the unit. I think this is a common error that the strings are unfortunately not properly displayed. But at least you can monitor the amount and the grams, and we can do this for all elements. Now, of course, if we want to go further, we can set here breakpoint, maybe remove this and set continue, and we can, okay, then we see that the amount is 1000, We can also iterate here now.
We can also look at the ingredient, which is the current one.
So the current one would be now something with milliliters. And if we run one more time in the loop, then we have something with unit. And if we run one more time, we have something with gram. Yeah, so this really works. Play with that around and use it in when you code something, because it's really helpful, especially if you introduce some bugs and want to find them. Yeah?
Is this compiler debug platform dependent? Because my JSON configuration file doesn't look anything like this.
Did you specify the LLDB extension when debugging and creating the JSON file? Yeah, if you click the first time on run, then there's this pop-up if you want to use GDB or LLDB. And then you choose LLDB, and then you should get the same configuration file, hopefully.
Yeah. Okay, then close this again. Please use the debugger. And now maybe we can build some small extension now to our program in the last 15 minutes. So, yeah. Do you want to continue? Yeah.
So I want to write a second class just so we see how we can reuse classes, and I want this vector that you created in the main now to have in this recipe. You also, I think, more or less printed a name here, and now I want to create a separate class, maybe also with some function. Yeah, so let's do this. We also already have the recipe header and source file.
So new class, new H and C file.
So always the header guards. And now I'll just create a class recipe.
I'm sorry that it resetted with the spaces. But also, this is also important for you. Please set your spaces to 2, because we will grade this.
And as we said, we want the name and, yeah, the vector. So same as in the main, we can just specify vector with the type we want to have to create some attribute of our recipe class. Then include, we need the string for the name, and here we need the vector, and then I guess we also need the ingredient, because yeah, we cannot find it. So we'll also include ingredient. Okay, seems to work. Again, we need a constructor. Same as in the ingredient, I'll just pass in all our private attributes we have, and then because we just have a very easy constructor, I'll just use the initializer list. So the first, again, is the attribute. Here we call the constructor of string and pass in the name.
But what if we maybe would say we want to add the ingredients later and just kind of have an empty list of ingredients at the beginning and just specify the name? Can we also do something like this?
Yeah. Then we could just leave this empty. So we do not call any constructor of the ingredients, or we could do something like this and do not pass anything into ingredients. This would amount to the same thing, which is we call the default constructor of the ingredients. So the ingredients with no parameter, which is with a vector just creates an empty vector. Yeah.
Okay, so basically we just have a name specified when we create the recipe and no ingredients at the very moment.
Yeah. But now I want to add an ingredient. So I'll create a method to add an ingredient. And this method, I'll just pass in an ingredient. And I do not want to make it const because I actually want to modify the vector and add this ingredient to it. I'll implement this method in the source file. So again, specify the class, specify the method we want to implement. We need the same signature. And then I'll just call ingredients, pushback, and add the ingredient. Okay. And I think, yeah, we also want a print method. This I can make const. Can implement it here.
Maybe now it also becomes apparent why we always need to write the class name before defining the method here, because now we have two print functions, one for the ingredient and one for the recipe. And if we would just have a print function with no arguments, this would not be distinguishable. But as we always write like recipe, colon print, or ingredient colon print, we really refer to the respective print function, and C++ knows which function is meant.
Yes, because C++ doesn't realize that this is the recipe CPP and we want to implement the recipe methods. So it cannot really distinguish if you're in the recipe CPP or in the ingredient CPP. And so just that it knows that we are not implementing this method here, we write recipe. Yeah.
So we need IO stream again because we do some output operation. And yeah, now we can print the ingredients with the print function of the ingredient.
So this is the same as you have seen in the main. And
yeah, basically we can now create the recipe here.
I also comment out everything.
What do we want to cook today?
Let's make a salad. Include the recipe. And now, what do we want to add? Add the ingredient. So we want to create a new ingredient here. And let's add salt to our salad. So maybe 1 teaspoon.
Maybe tomatoes.
So maybe 1 tomato. Something like this.
Yeah, and so on and so forth, yeah.
And now that's printed.
Okay, what do we get as an error message here?
Oh, sorry. No such file main.cpp behind the wrong terminal.
Wrong folder, yeah. But still we get an error here.
Undefined reference recipe at ingredient.
Where do you see that?
Here.
Okay, and if you scroll down again, it says Clang++ linker command failed with exit code 1. This is probably one error message that every one of you will see at some point. And this usually refers that some method of any of your classes is not implemented, or the implementation cannot be found.
Yeah, so if you think back to introduction to structured programming, now we get a linker error, not a compiler error. So it does not tell us really, we do not get any errors in here in VS Code, where we see the compiler error, so it does not find this method. But we get a linker error. So what happened is that the compiler thinks that the add ingredient function exists because we included the recipe, and in the recipe, I declared it, but I did not compile the recipe.cpp file, and therefore we did not have any implementation of this function.
So it's always important to specify all CPP files, and of course, if you declare a method in the HPP file, you also need to implement it somewhere.
Yes, because in Introduction to Structured Programming we said if we declare a function, we just tell the compiler this function exists and we can use it, but if we then do not define it, we get the linker error.
Okay, now it worked.
Okay, let's execute it, and yeah, we get our salad.
Okay, this is really nice.
So what if we make a mistake now, and for example add sugar to our salad, and maybe way too much?
I mean, big brother.
So I called add ingredient now and accidentally added sugar to our salad. So if I print this now, we can see, oh no, we have sugar in here. So how could we change that? Well, we could write a remove function where we specify, for example, the name and then remove this from this vector. Or as we have in here we actually have a set ingredient function.
Also, this is the add ingredient, it's not a set ingredient. Yeah, okay.
And what I want to do is that instead of here just adding the ingredient, this search through all ingredients, and if something with the same name already exists, it just overrides the amount and the unit, or overrides the whole ingredient. So I'll change this from an add ingredient to a set ingredient. Also change this in the main. I'll move this line up, and then maybe in here our hopes would be that if we just specify an ingredient with the same name, we can say something like this, or maybe just something way less.
You want to have a sweet salad. Okay, yeah.
So, of course, we now also need to change the implementation here, not in the ingredient, but in the recipe CPP. Yeah. It also tells us here again that we have an error because add ingredient does not exist. We want set ingredient. And instead of just adding this, we want to search through our ingredients. So how would we do this? Well, let's first loop over them. But we actually want to change the ingredient. We said we want to override it, so I'll get a reference to it. And then I'll check if the ingredient get name. Now we need to use the getter. Oh,
you have some naming conflict here.
I'll call this new ingredient.
You brought up.
And if the name of the new ingredient is the same as the name of the old ingredient, so the ingredient we are currently looking at in this loop, then we want to override it. And we need to use the getter here because we are in the recipe class and not in the ingredient class, so we can't access the name directly. And what I want to do now is just override it, and then I'll just return, so we never get to this line where we add it at the end of the recipe.
So in case you don't find the new ingredient in the list, then we go through the loop. We never have a true comparison here. So this loop ends and we will push back the element.
And maybe another cool thing you can notice here is that here we have this string and we can actually compare it with this equal sign. So this works now if we use the string class instead of C strings. And I think in the main, I already tried to overwrite this. And we can see now we printed 2 times and we overwrote the ingredient.
Okay. Have any questions regarding the recipe? Okay, maybe switch back to the slides.
Yes, we have all this code again in the slides.
Yeah, so last time we've seen further topics. Unfortunately, the time is already more or less over for us. So we'll postpone this to the next week. Also, our nice heap array, we'll do this next week. So we'll implement the vector on our own. You will see this next week. But just summarize what we have seen today. We defined the classes. We created our first classes. We used them. We had the attributes. We had constructors. We also had methods to modify them. We used a very nice vector now, also in the recipe class, to store multiple elements without having to deal with dynamic memory. All things you will then also need in the assignment 1 in next week or in 2 weeks.
Yeah.
And don't forget to use the debugger.
Yeah, and I hope with today's practicals, we somehow showed you how you could structure code and how you do things in C++, because it's rather different than in C.
Yeah, and today's lecture then will also continue with further topics regarding classes, and I think we will start then in 10 minutes, so at 5:30. Thank you.